Suppose the return on S&P 500 over a period of 10 years in percentage terms is 5.89, 7.62, negative 6, 11, 8, 7, 2.39, 4.55, 9.55, the time series mean of the data set. So time series, because we have a historical data, and time series mean is nothing but simply an arithmetic average. So we just have to add up all the numbers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So take all these 10 values, in fact it was given, add them up and then divide. So 5.89 plus 7.62 plus, in fact minus 6.23 plus 11.3 plus 8.45 plus 7.36 minus 2.39 plus 4.59 plus 5.82 plus 9.55 divided by 10, which would give us a value of 5.19. So this would be your answer. Next question. A client asks you for valuation analysis of 9 stock US common stock portfolio given below. 9 stock portfolio. The stock are equally weighted. One valuation measures that use is P. The values in table are as of 3rd August 2013. For comparison purpose, the consensus PE on the S&P 500 was 22.49 at that time. Using the data given, the median PE and mean PE are. So we have EPS, we have PE. We don't need this. We just need to find out median and mean. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. So median has to be 9 plus 1 divided by 2, the 5th value. So we'll have to arrange it in order. So the smallest number is 15. Second one is 16. Then 17. 19. And 5th value is 21.03. So median has to be 21.03. And technically we don't have to solve for mean because we know this has to be the answer. And mean would of course be total of all of them divided by 9. Next one. Given in the table are the credit ratings of debt instruments on certain companies. So we have different companies and different credit ratings. The model credit rating, the one which is repeated with maximum frequency. 1, 2 and 3. There is no other rating which is repeated 3 times. Therefore the model rating would be Baa plus. Next one. Estimated average asset allocation of pension fund as well as respective asset class returns are as follows. Equity, asset allocation and asset class returns. Calculate weighted average return earned by the fund. Okay, so with this data you just have to calculate weighted average. So let's in fact do it together. These are the weights, these are the class return. So 2.3 into 0.3536 plus bracket open. It has gone wrong. Doing it again. 2.3 into 0.3556 plus bracket open 5.5 negative into 0.0830 bracket close plus bracket open 7 into 0.4567 bracket close plus bracket open 8.4 into 0.0180 bracket close equal to plus bracket open 12 into 0.0626 bracket close equal to plus bracket open 3.6 into 0.0241 bracket close equal to, weighted average would be 4.54. So the answer would be 4.46. Was it 4. Have you anyone else tried? 4. 4.46? Okay, so this is the closest choice, therefore that's your answer. Next one. As an analyst, you are examining the recent 6 years of total return on mid cap. Calculate geometric mean return of the data set. Calculate a geometric mean of these values. So we know that geometric mean is multiplication of all of them and taking the appropriate root. In this case 1, 2, 3, 4, 5, 6, sixth root. So I would solve it here parallelly. 1.0830 into 1.0686 into 0.9057 into 1.0522 into 1.1174 into 1.1091. Now we have to take sixth root of this number. So y raised to x, bracket open, 1 divided by 6, bracket close, equal to 1.053, that means 5.34. So the correct answer would be 5.3459. Next question. From the given dataset having different values, is the harmonic mean greater than datasets arithmetic mean and geometric mean? The answer is no and no, which is shown correctly in the option A, which is here. Because we know that arithmetic mean is highest, then geometric mean, and the lowest number is the harmonic mean. Table below represents the random observations with their respective means. The cumulative relative frequency of interval 7 to 8 is. Calculate cumulative relative frequency of interval 7 to 8. So cumulative means additive from the beginning, and relative means in percentage terms. Total number of values that we have 1, 2, 3, 4, 5, 6, 7. How many of them are less than 8? Because cumulative will include all the values which were above them. So 1, 2, 3, and the last one, this was the fourth value. Therefore cumulative relative frequency would be 4 divided by 7, which would be 4 divided by 7, which would be 57.14. So this is your answer. Next question. Calculate sample standard variance simply by using the data and stat function of your calculator. So we have multiple value sets here. We just have to insert them into the calculator. Second 7 to insert the data function, and second and clear work to delete if there was anything saved. X1 would be 17.6, 17.36, enter. Then X2 would be 11.24, enter. X3 would be 6.02, enter. X4 would be 2.15, enter. X5 would be 5.36, negative, enter. X6 16.25, negative, enter. X7 0.5, enter. X8 3.25, 2, enter. X8 is negative 3.2, enter. X9 is 6.59, enter. And X10 is 8.6, enter. Then second and 8, which will take us to the stat function. We want sample standard variance, so we take Sx, which is the standard deviation, take a square of this number, second, and sorry, something went wrong in the data. 16.25, 11.25, 6.02, 2.15, 5.36. Oh yes, that's exorbitant. 16.25. Seventh is 0.5, negative 3.2, 6.59, 8.6. Second and 8, go for Sx and take a square, 90.30, and therefore the answer is 90.31 in the option. Moving further, we have a data here, 1992, 93, 94, 95, 96 returns. Compute semi-deviation. So the formula for standard deviation is x minus x bar square divided by n minus 1 under root. In case of semi-deviation, or at times also called as downside deviation, the only change you make is take only those values which are less than the x bar and then say x minus x bar summation. So how do we deal with this? Step number 1 would be to calculate arithmetic mean of these values. So let's do it. First value would be 15.3. So 15.3 plus 20.8 plus 8.6 minus 6.3 minus 11.5, 26.9 divided by 5, which would give us a mean value of 5.38. Then we have to go and search that which of these values are less than 5.38, and we in this case have only two values. What we would be required to do is summation of x being the values which are less than mean, minus x bar square, and again we can do that using calculator. So 6.3 negative minus 5.38 and square of this value STO1, 11.5 negative minus 5.38 square of this value STO2. So now we have summation of x minus x bar square. The trick here is that the denominator does not change. That means the denominator still be n minus 1, which is 5 minus 1, 4. So in that case, this value divided by 4 and then under root, that would give us 8.44, which is RCL1 plus RCL2 divided by 4 under root, which would be 10.26. So 10.26 is the answer. Okay, now generally if you would refer to any of the books on statistics, this n would always be given as those number of values which are less than the mean. So ideally this should have been 2, but as per the examples in the CFA curriculum, they have taken this n as a total number of values. Okay, so on the exam simply remember that this n has to be, in this example, 5 minus 1. The only thing that changes is how many values we take in the numerator. Moving forward. In the previous semi-deviation example, if our objective is to earn a return of 10%, calculate semi-variance. So now, or target variance. So now we want to earn a return which is more than 10. How many values are less than 10? 1, 2 and 3. So x minus x bar square divided by, in this example, 4, and we are not going to take under root because what we want is a variance here. So let's do it on the calculator again. 8.6 minus 10 x square STO1, 6.3 negative minus 10 x square STO2, 11.5 negative minus 10 x square STO3, RCL1 plus RCL2 plus RCL3 divided by 4, that would give us 182.475. So the answer is 182.48% square, and we know that variance, the unit is always in squares. Next question. The arithmetic mean monthly return and the standard deviation of monthly returns on the FTSE Eurotop 300 were 0.80 and 4.52 respectively. During 1980 to 2010 period, according to Shibashov's inequality, calculate the endpoints that contain at least 84% of the monthly returns. Okay, we know that the formula for Shibashov's inequality is 1 minus 1 divided by k square. We have to find out that k which gives us probability of 84%. So we can start with, we know that 2 gives us 75, so slightly higher than 2. So let's start with 3. I also know that, but I can't show while recording it. I can't show it. This has to be 2.5. So okay, let's say 2.5, and then we take an inverse. We make the number negative, and then we say plus 1, and that gives us, let me do it again, 2.5 square inverse, making the number negative, plus 1, that would give us 84. That means that k is, in this example, 2.5. So we're looking at data points which are 2.5 standard deviation on either sides. So your mean is 0.8 plus 2.5 into 4.52. So 4.52 into 2.5 plus 0.80. The upper boundary is going to be 12.1, and therefore the answer is minus 10.5 to 12.1. So which means in this question we had to reverse calculate k based on the probability. Moving further. A long-term corporate bond in Canada has mean return of 7.3, standard deviation of 9. It has a coupon rate of 8%. Coefficient of variation for this bond. Coefficient of variation is calculated as standard deviation divided by mean. Standard deviation in this case is 9, and the mean is given as 7.3. So 9 divided by 7.3, that would give us a value of 1.23. Moving further. You want to calculate coefficient of variation of a portfolio. Following table reports annual returns of the portfolio and the risk-free rate over the most recent 5 years. The coefficient of variation using population standard deviation is closest to. So again, what we need to do is we need to calculate mean of this data. We need to calculate sigma x of this data, and then sigma x divided by mean is going to be your final answer. This is not to be put to use. So we will use financial calculator to do this. Second 7 to insert the data function. Second clear work to delete prior memories. X1 would be 6, enter. We don't need a Y1. Then this would be 3, negative, enter. X3 would be 5, enter. X4 would be 13, enter. X5 would be 5, enter. Second and 8. The sigma x is 5, so STO1, and x bar is 5.2, STO2. RCL1 divided by RCL2, that would give us an answer of 0.97. So 0.97, which means the answer in this case in the option is 0.98. Going ahead. Given below are the annual mean returns and standard deviations for several asset classes. So which asset classes? S&P, small, long-term corporate, government. The most risky asset class using coefficient of variation as a measure of relative dispersion. The most risky asset class. So we'll have to calculate coefficient of variation for each one of them, which is simply standard deviation divided by mean. So 19.8 divided by 13.7, this would be 1.44. 40.2 divided by 18.2, 2.20. We don't need to actually calculate this, but just so that we have all the numbers. This would be 1.10, and 9.1 divided by 6.9, this would be 1.31. Now which one of these is most riskiest? The one which will have highest coefficient of variation, and therefore in that case the answer is going to be small stock, which you could have guessed without solving. Small stock. Next question. As a risk manager, you are evaluating two mutual funds, alpha, beta, mean, standard deviation. If the mean annual risk-free rate of return is 5.1%, what fund you would like to invest in? These kind of investment decisions would be taken based on Sharpe ratio, because Sharpe ratio also factors in the risk-free rate of return. So let's calculate Sharpe ratio for arithmetic mean. The formula is return on portfolio minus RFR divided by standard deviation. So 13.44 minus RFR of 5.10 divided by standard deviation of 21.36. This will give us a Sharpe ratio of 0.39. Then 10.56 minus 5.10 divided by 12.65. This would give us a Sharpe ratio of 0.43. And which one is better? The higher Sharpe ratio, and therefore the investment selection would be of beta. So lower the coefficient of variation, better. Higher the Sharpe ratio, better it is. Next question. Returns on a fund over 5 years are as follows. Calculate the skewness of the data set. So we know that mean is the first moment of data, standard deviation is second, skewness is third, and kurtosis is fourth. So now formula for skewness: n divided by n minus 1 divided by n minus 2 multiplied with x minus x bar raised to 3 divided by sample standard deviation raised to 3. So we will have to calculate each of the value. This should be summation. We'll have to calculate each of the values and then insert that into the formula. To calculate sigma x, we can simply use the stat function. However, this value we might have to calculate manually. So let's do it together. Let's insert these values into data function first. X1 would be 28.6. X2 would be 22.4. X3 would be 8.1. X4 would be 2.3 negative. And X5 would be 13.5 positive. Then go to second 8. And in this case now search for X bar 14.06. STO 9. So that I have put into the 9th memory slot. Coming out of the data function now. Now what we need is this, which is x minus x bar raised to 3. So 28.6 minus RCL 9, where we have stored the mean. This value raised to 3 STO 1. In the same fashion, 22.4 minus RCL 9 raised to x3 equal to STO 2. 8.1 minus RCL 9 var is to x3 equal to STO3, 2.3 negative minus RCL9, var is to x3 equal to STO4, 13.5 minus RCL9, var is to x3 equal to STO5, RCL1 plus RCL2 plus RCL3 plus RCL4 plus RCL5 equal to, let me put this in 8th memory slot, so STO8. So now this value we have in the 8th slot. Let us go and find out what is the SX which is already there. So 2nd and 8, search for SX. This value raised to 3, 1766. Let me put this in the 7th memory slot, so STO7. So this is in 7, and now our life is relatively easier. So RCL 8 divided by RCL 7 multiplied with, total values are 5, divided by 4 divided by 3, that would give us a skewness of minus 0.22. Let's check if we have option. Yes, we do. Then this is your answer. Will you be able to remember the formula? So maybe you can just write down these two formulas. Skewness n divided by n minus 1 to n minus 2, x minus x bar raised to 3 divided by sample standard deviation raised to 3. This is actually a sample skewness formula, and it's a summation here, and a sample kurtosis formula. We know it's the fourth moment, so n into n plus 1 divided by n minus 1, n minus 2, n minus 3, summation of multiplied with x minus x bar raised to 4 divided by sigma x raised to 4. Moving on to next question. A 5-year record of two portfolio is being evaluated, portfolio A and B, monthly return, standard deviation, skewness and kurtosis. Based on this information, which among the two is a better risk reward portfolio? So how we solve this is, we have to look at one measure one by one. A and B, the returns are same, and therefore both of them seem to be a similar in terms of returns. Standard deviation of A is higher, so this gets a negative notch, and we select this. Skewness is same, so again both of them we don't really worry too much, but it's negative, so both of them seem to be more riskier. And kurtosis of first one is higher, so again there's a possibility of large amount of shifts, and therefore in that case the security which is to be selected is B. Moving on to next one. Tony gathered the following information about portfolio's performance over the past 5 years. Standard deviation portfolio beta. The risk-free rate over the same period was 6%. The coefficient of variation and Sharpe ratio respectively for the portfolio are closest to. Please solve. Calculate coefficient of variation and Sharpe ratio. Yes, do we have the answer? Coefficient of variation would be Standard deviation divided by mean return. So 16.2 divided by 12.5, coefficient of variation would be 1.296. 1.296, that means we have to choose between B and C. Sharp ratio would be returns, expected returns. So expected returns are 12.5. RFR is 12.5. RFR is 6 divided by standard deviation of 0.2, which will give us a sharp of 0.40. So therefore the answer is B, which is here. Moving further,